Alright, here we have a 14 kilogram box that slides to a stop in 3 seconds. And it wants us to use a kinematic equation to calculate the acceleration of the object. Alright, so if we were to draw a free body diagram of this object, we would have, while it's slowing down and stopping, we have the force of weight and the normal force, and then we have friction that is causing it to slow down and stop. So we're going to figure out what variables we have so we can go ahead and plug this into a kinematic equation and solve for acceleration. Well, we're trying to solve for acceleration, so that's one of our variables. And it was moving. We don't know what the initial velocity was, but it stopped. So our final velocity is 0 meters per second. And the delta x is 6 meters. And our time is 3 seconds, because it said it took 3 seconds to come to a stop. Alright, and we are missing our initial velocity altogether. So we're going to use the equation without initial velocity, which is delta x equals final velocity times time minus 1/2 a t squared. So we plug these in, we get 6 equals, and then our final velocity is 0. 0 times time is still 0. So we have negative 1/2 a 3 squared, because 3 is our time. So that gives us negative 1/2 a, and then 3 squared is equal to 9. 9 times negative 1/2 is negative 4.5, and we're still multiplying that by acceleration. If you needed to double check that in your calculator, you could just do 1/2, well, it'd be negative 1/2 times 9, you get negative 4.5. Alright, so to solve for acceleration, we'll have to divide both sides by negative 4.5. This here cancels out, and then we have acceleration equals 6 over negative 4.5. So our acceleration is equal to 6 over negative 4.5, which equals negative 1.3. So our acceleration is negative 1.3, and we can go ahead and say that our acceleration up here is negative 1.3 meters per second squared. Alright, now it wants us to calculate the force of friction that stopped the object. Well, we know that force equals mass times acceleration, and so our mass is 14 kilograms, and our acceleration is negative 1.3, and when we multiply that out, 14 times negative 1.3, we get negative 18.2. It's negative because the box is trying to move to the right, but the frictional force is opposing it, moving to the left. So this is negative 18.2 newtons, or 18.2 newtons, to the left. Alright, since it was sliding, was this kinetic or static friction? Alright, well, once it stops, we're going to have a static friction. So right here, during the after visual, we would have to apply static friction to get it to move again, but while it's slowing down and stopping, it has a kinetic friction because it was moving. What is the normal force acting on the object? Alright, well we know that since we have no other vertical forces, our normal force is going to be equal and opposite to the force of weight. The force of weight is mass times gravity, which is equal to 14 times 9.8. We use the magnitude of gravity. So this is technically 9.8 down. And when we multiply that out, we get 14 times 9.8, and that is 137.2. Newtons, and then that's down. But we're not trying to solve for the force of weight, we're trying to solve for the normal force. So if the force of weight is 137.2 newtons down, the normal force is going to equal 137.2 newtons up. Alright, so there's our normal force. And now it says calculate the coefficient of friction of the surface. Alright, well we know that the formula for kinetic friction is mu k, or the kinetic friction coefficient, times the normal force. Alright, so to solve for this coefficient, which is what it's asking us to do, we would have to divide both sides by the normal force. Fn over Fn cancels out, and so we have our kinetic friction coefficient that equals our kinetic friction over our normal force. Alright, so what we're going to do, our kinetic friction is 18.2, but we're actually going to use the magnitude of our kinetic friction, which is 18.2 newtons to the left. So we're going to write 18.2, and that's over our normal force, 137.2. And that is equal 18.2 over 137.2 equals 0.13. So our kinetic friction coefficient is 0.13. And since this is newtons over newtons, and that cancels out, our kinetic friction coefficient actually has no units.